Thank you, students. Today I discuss about the characteristics of sound. There are three main characteristics of the sound. First one is loudness, second is pitch, and third is quality. In this video, I discuss about only loudness. What is loudness? Actually, loudness is the sensation of our ear, and it is measured by the measurement of intensity of sound. That is why you have to know what is intensity. Intensity of sound is defined as the amount of sound energy transferred through unit area placed perpendicular to the direction of the propagation of sound per unit time. That means if the sound propagates in that direction, then you consider a unit area, say this is a unit area, which is perpendicular to the direction of the propagation of sound. Unit area which is perpendicular to the propagation of sound. Now, the amount of sound energy passed through that unit area in unit time is the measurement of intensity of sound. So the intensity of sound is equal to sound energy divided by area divided by time, must be in second. This is the measurement of the intensity. We know that energy by time, it is the power. So the intensity of sound will be power divided by area. This is the intensity. Now this loudness of sound depends on the 5 to 6 factors. First of all, loudness depends on the amplitude of the sound wave or the amplitude of the vibrating object from which sound is produced. The loudness of the sound is directly proportional to the square of the amplitude. That means if the amplitude of the sound wave is more, then its loudness will be more. And but how much more? It will be the square of the amplitude. For example, take two waves. Is the wave A, it is the black in color, and whose amplitude is 3 unit, 1, 2, 3, 3 unit. And another wave, it is B, the red in color, and its amplitude is 1. So as compared to A and B, amplitude of A is 3 times more than that of B. So the wave A have more louder, is a more louder than B. But how much louder? As the intensity is 3 times more, then the loudness will be more by 3 square is equal to 9 times. Here the wave A has 3 times more amplitude than wave B. So the loudness of wave A will be 3 square equal to 9 times more than that of wave B. So the loudness is more by square of its amplitude. The L is directly proportional to the amplitude square. Now the second factor on which the loudness of the sound depends on, second one is the distance between the source and the listener. If the listener is closer to the source of the sound, then the sound will be louder. If the listener is far away from the source of the sound, then the loudness of the sound will be smaller. We know it. So the loudness of the sound depends on the distance between the source and the listener. More distance, less loudness. Less distance, more loudness. Now, the third one is the surface area of the vibrating object. We know that the sound is produced by the vibration of the object. If the surface area of the vibrating object is more, then louder sound is produced. For example, say a tabla and a dhak. Both are the instrument made by membrane and produce a sound by the vibration of that membrane. But dhak is the bigger in size and tabla is the smaller in size. That when they produce sound, the loudness of the sound of the dhak is more because its vibrating surface, vibrating screen is bigger in size than the tabla. Now take another example, our voice. A man's voice is more louder than the woman's voice. Why? Because of man's vocal cord is bigger in size than the woman's vocal cord. As the man's vocal cord is bigger in size, then it produces the louder sound than the voice of woman. Now the next point on which the loudness of the sound depends on. Presence of resonant object. First of all, you have to know what is resonant object. Resonant object or resonant body is a system of body that present with the main vibrating object, and this system of body is forced to vibrate with the frequency of the vibrating object, and as a result the total vibrating object, that means equivalent vibrating object, or the size of the total vibrating object increases with the original vibrating object and the resonant object, and that is why the intensity or the loudness of the sound increases. A resonant object is the system of body that present with the vibrating body, and this system of body is forced to vibrate with the frequency nearly to the original vibration, original frequency of that vibrating object, and this system of body is known as the resonant object. In presence of this resonant object, the loudness of the sound increases. Here one example is there. Say air column in hollow box attached with the stringed musical instrument acts as a resonant body. Guitar, it is a string instrument. When the sound is produced due to the vibration of this string, and the sound produced by that string is not too much loud. To increase the loudness of that sound, a hollow box is attached, hollow wooden box is attached with that string. The air column inside that hollow box acts as a resonant object. When string is vibrated, then with that vibration, the air column inside the hollow box also starts to vibrate with the same frequency of the string and produce a louder sound. This is the resonant object. So in presence of the resonant object, the intensity of sound increases. Now the next or the fifth point of the on which the loudness of the sound depends on, and that is the density of the gaseous medium. If the density of the gaseous medium increases, then the intensity of the sound also increases. For example, the hydrogen gas and oxygen gas. Oxygen gas is more denser than oxygen gas. The oxygen gas is more denser than hydrogen gas, and that is why the intensity of sound or loudness of the sound through the oxygen gas is more than that of the hydrogen gas. Now the last one is the flow of air. When sound propagates in the same direction of the air flow, the loudness of the sound increases. That means if the the air flows in that direction, and also the listener is present in the same direction of the propagation of, that means flow of air, then the louder sound is reaches to the listener. But if airflow is done in that direction, but the listener is present here, that means the listener is present in the opposite direction of the airflow, and in that case the loudness of the sound reaches to the listener will be less. These are the factors on which the loudness of the sound depends on. Ultimately, the loudness is nothing but the measurement of the intensity of sound. But it is not exactly, it is the intensity of the sound. Now, the unit of intensity and the loudness. According to the definition of intensity, already we know that intensity is equal to energy, but that means sound energy carried through the unit area in unit time. It is the intensity. Also, we discussed earlier, energy by time is the power, so it is the power by time. Now, what will be the unit? SI unit of intensity will be from this formula is the energy, that means joule meter square area by time is the second to the power minus 1 or per second. So the energy, so the joule per meter per second, which can be written as joule meter to the power minus 1 is or the second to the power minus 1. But if you write down the unit from this formula, it is a power by area. The unit of power in SI system is watt. So watt per meter square. This is the unit of intensity of sound. But what is the unit of loudness? Loudness is measured by the unit decibel, which is known as written as dB, must be D small letter, B is capital letter. It is a smaller unit, its bigger unit is bell. When you write down bell, must be bell written is small b el bell, but when you write down in symbolized form, then it will be capital B. 1 decibel is equal to 1 by 10th part of a bell. So from this discussion, we come to know that loudness and intensity are not same, but loudness is measured by the intensity. That means if the intensity is more, then the loudness of the sound will be more. If the loudness in the intensity is less, then the loudness of the sound is less. Now, thank you.